Okay, today we're going to do slope or rate of change. This is a vocab word, so definitely take a look at that vocab term when you're studying. Slope is super important, so I would definitely recommend making sure you do the practice problems. All right, let's get right at it. So we know that this is our y-axis, right? And this is our x-axis. And so if we're going to label our points, right, we have here, this is 4, 3, right? So 4 minutes gives us 3 feet in distance. And then right here we have 9 minutes gives us 8. So if we were to connect this, right? So this is showing us rate of change. So this is our distance and our time. And we're going to say this example is like a slug, right? So here's the slug's house. Here's the path that the slug has taken. Here's our little slug, however you want to draw him. Right? Okay, I'm not an artist, I'm a math teacher. Okay, so let's say, right, at 4 minutes, he was 3 feet from his house. Right? So this is 3 feet. If we look at the clock, it was 4 minutes. And then here, at 9 minutes, he's 7 feet away. Right? So he's moving in a straight line away from his house. This is going to be represented using our x-axis is time and our y-axis is distance. So we want to calculate his slope, right? So we have our slope, our rate of change. We have 7 feet minus 3 feet over 9 minutes minus 4 minutes. So that gives us 4 feet every 5 minutes, right? So when you're thinking of slope, right, we're gonna put a note over here, right? Slope rate of change usually has time in the denominator. Let me do change of time. I'll just do time. Time in the denominator. Example, meters, seconds, minutes, years, etc. Right? So in real world problems. So, right, in word problems. Okay, but if we look here, we have a lot of ways to do slope. So we can do change in y over change in x. We could have delta y over delta x. So this is called delta. It's a Greek letter. And it pretty much just means change of. Okay, we could have rise over run. That's a really common one. Or we could have the formal definition, formal equation. M equals y2 minus y1 over x2 minus x1. So I'd say rise over run is the most common, and then this formal one. So, right, if we were to use these 2 points, this is saying y of the second point. So, oh, did I do the wrong feet? 7 feet. I labeled this wrong. This is 7. My bad. Hopefully you didn't use marker like me. Okay, so right, this is, if I had these 2 points, right, let's say I made this, let's say I made this one x1, y1, x2, y2. So this is pretty much saying x of the first point, y of the first point, x of the second point, y of the second point. So y of the second point is 7, y of the first point is 3, x of the second point is 9, and then x of the first point is 4. right? So maybe if I do this in a different color, right? So if this first point was purple, well, now a purple blue, right? So we have and these are the corresponding points, right? And so this is our slope equation, right? Stuff from one point minus stuff from the second point. Okay, so this will make more sense with a few more examples. So let's go through some examples. Okay, so we want to find the slope and we're given these points. So remember, our slope is y1 minus, or y2 minus y1 over x2 minus x1. So let's say that this is x1, y1, x2, y2. So that is 4 minus 16 all over negative 20 minus 12. This becomes negative 14. This becomes negative 32. We want to simplify that. So we're going to, remember, a negative over a negative becomes a positive. And then we see these are both divisible by 2, so we get 7 over 16. Oh wait, 4 minus is negative 12. 4 minus 16 is negative 12. 12, and then this becomes 6. 6 over 16, and that is 3 over 8. Right, so it's really common to make mistakes. Like, I make mistakes all the time. The biggest thing is checking it, right? Going back and making sure that you check and fix your mistakes. Because in math, when it's wrong, even if I could see your work is good, you're still going to get some points wrong. So you always want to double check. All right, so 3/8. Let's give another example. So we have, let's say the points 21, negative 10, and 7, 27. Okay, so we're going to do two methods, right? I want to show you that you can actually do two. So first, point, let's have x1, y1, x1, y1 is going to be 21, negative 10. x2, y2 is going to be 7, 27. And then in the second version, we're gonna switch it. x1, y1 is gonna be the 7, 27, and x2, y2 is gonna be the 21, negative 10. So I just want to show you, it doesn't matter which point you do first. You just have to make sure you are keeping them together. Like, it's always gonna be y minus y and x minus x, not, you know, x and y minus each other. So you just want to keep it in the right order. So let's do this, right? So we have 27 minus negative 10 over 7 minus 21. We get 37 over negative 14. And then here, instead of doing that minus that, we're going to do, right, we're going to do negative 10 minus 27 over 21 minus 7. So we get negative 37 over 14. Right, so they're the same. We get negative 37 over 14. So it doesn't matter which point you pick for your y1, for your first point or your second point, as long as you are consistent. Okay, so we're going to look at graphs now. So we're going to do two different methods. We're going to look for patterns. And then our second method, points. y2 minus y1 over x2 minus x1. Okay, so for our first method, let's look for our pattern. So let's do this in blue, I guess. So this is plus 4, plus 4, plus 4, plus 4, plus 1, plus 1, plus 1, plus 1. So we found a pattern, right? Pattern, check. So we have rise over run. Remember, rise is our y. change in y over change in x. So it's an x. So we have plus 4 over plus 1. So that equals 4. Okay, and then over here we're going to do our point method. So we're just going to pick any two random points, right? So let's just pick, you know, these two. So we have 2, 11, and 3, 15, right? So we have 15 minus 11 over 3 minus 1 equals 4. Sorry, 3 minus 2 over 2 equals 4 over 1 equals 4. Nice. Let's pick points that are farther apart, right? Let's do 1 and 7 and 4 and 19. Right? It doesn't matter which 2 points you can do. You should all get the same answer. So let's do it the other way. So instead of making this one minus this one, let's do 7 minus 19 over 1 minus 4. We get negative 12 over negative 3. That simplifies to 4. Right? So you could do any method. You could look for patterns, or you could do the points method, which is like what we did up here. Okay, let's take a look and see if it works over here, right? So we have minus 5, minus 5, minus 5, minus 5, plus 3, plus 3, plus 3, plus 3. So the pattern, there's definitely a pattern. And we're going to do change in y over change in x. So change in our y is negative 5. Change in our x is plus 3. So our slope is negative 5 over 3. And then let's take 2 points. Let's do 1 and 17 and 7 and 7. So we'll do 17 minus 7 over 1 minus 7 equals 10 over negative 6. We simplify this, it becomes negative 5 over 3. All right, last one. Plus 12 plus 10 plus 6 plus 5. So there's not a clear pattern. So we're going to have to do the points version. So let's pick these. Let's pick 4, 12, 14, and 17. So let's do 17 minus 12 over 14 minus 4 equals 5 over 10 equals 1/2. So our slope is 1/2. Let's just take 2 other points to prove that it works. Negative 8 and 6, 14 and 17. So instead of doing 17 minus 6, let's switch it around, right? Let's do 6 minus 17 over negative 8 minus 14. We get negative 11 over negative 22. That equals 1/2. Right? So the cool thing about slope is that with a linear function, with a line, no matter what points you look at, you're always going to get the same slope. Okay. Okay, so something that's really important is being able to look at things in all different ways. So if you remember from previous lessons, right, we had Vang. So we have visual, algebraic, or not visual. Verbal, algebraic, numerical, and graph. Right, so let's take a look at these. So equations is algebraic. So let's take an example. Let's do y equals 3 over 4x plus 1 and y equals 2 minus 2 over 5x. So if we're looking here, slope equals 3 over 4, right? It's the number in front of x. So here, right, even though the x in this one, right, it was x and then the constant, but here it's the constant and then x. So we just want to make sure that we're always looking for the number in front of x, not just the number that's right to the right of the equal sign. So right here we have our m equals negative 2 over 5. Right, we can use m and slope interchangeably. Doesn't matter. So right, this could be like, oh, he's losing, 2 hairs every 5 days. And this one could be, oh, he's gaining $3 every 4 minutes, right? So This is just an example of something algebraic that you'll see really commonly and you want to be able to find the slope. Let's look at the graph. So when we're doing the graph, we want to look at the points and we can look at our rise over our run. All right, so if we look here, remember we're going from left to right. So our rise is actually, it's dropping down 2. So if we have rise over run is -2 over, and then it's moving over 4. So our slope is -1/2. We could also look at points, right? We could look at, here we have 0, 2, and then we have 4, 0. So we could do 2 minus 0, 0 minus 4. We get 2 over -4 equals -1/2 again. So sometimes you can just see it by looking at the grid lines, and sometimes you have to calculate it with a point. All right, what about this one? This one, they didn't give us the points, but we can put them on ourselves, right? We could see that it's intersecting these, you know, crosses right here. There's an intersection right here. Here's another intersection. So now we can see, right? Our rise is 1, 2, 3, 4. Change in y, change in x. And our change in x is 1. We can add positives or negatives to make this more obvious, right? Because this is positive x, positive y. And that gives us a slope of 4. Okay, right. So verbal. Verbal is just being able to read a word problem and convert it. So Bob has 40 Skittles. He eats 5 Skittles every 3 minutes. So this is actually unimportant when we're thinking of rate of change, right? We want to think like this is telling us, right? Remember on the back side how I said slope usually has time in the denominator? So if we look here, like this is a time, right? So we could say 5 Skittles every 3 minutes. Spelling Skittles wrong. Skittles. All right, and here, it runs 3 miles every 24 minutes. She already has 5 miles. This is just extra information for this problem. It could be useful if I asked you a further question, but right now I'm just asking for slope. So we have 3 miles every 24 minutes. So we're going to simplify that to 1 mile per 8 minutes. Right, and our time is usually on the denominator. Okay, almost done. We just want to get used to our different slopes. So these are all vocab terms, right? Positive slope, negative slope, zero slope, and undefined slope. So always, I'm going to write this in a different color because it's that important. Always read left to right like a book to find positive or negative slope. So you want to think about like climbing a mountain, right? So we're going from left to right. And let's say we have a person right here. And he's going from left to right, so he's going down, right? So this is a negative slope. Going down from left to right. All right, and then here we're going from left to right, so we're starting right here, right? And he's going uphill, he's going on a hike, so it's positive, right? A positive slope. Yeah. Okay, then we get 2 special cases, right? Special cases. Okay, so when it's flat like this, so just to be careful when you're reading this, right? This is our x-axis, this is our y-axis, so this is our line right here, right? When it's flat, this is a 0 slope. Right? We have this guy, he's just walking on a nice flat road. It's not uphill or downhill, it's just 0 slope, right? And why does this work, right? Why is m equals 0? Okay, so let's take 2 points, right? Let's take this point and let's take this point. So we have 1, 0, 1, 2, sorry, that's not 0. This is 0. So we have 1, 4, and then we have 3, 4. Right? Let's do our slope equation. Let's see if it works. So we have change in y over change in x. So we're going to 4 minus 4 over 3 minus 1. We get 0 over 2. 0 over 2 is 0, right? 0 over anything is 0, unless it's over 0, right? But as long as 0 is on top and there's a number on the bottom, this is always going to be 0. So this is our 0 slope. It's flat. He's not going uphill or positive. He's not going downhill or negative. It's flat. Okay, and then the last special case is trickier. It's undefined. Usually the best way to remember is to know positive, negative, and 0, and just know your last option is undefined. But undefined is up and down. So like, let's take 2 points here, right? Let's take this point and this point, right? This is 4, 2. And then this is 4, negative 1. Let me label these here. 3, 4, 1, 4. Okay, so if I was to do my slope, right? y2 minus y1 over x2 minus x1, we get, let's say this is y2. 2 minus negative 1, 4 minus 4, we get 3 over 0, right? We're not allowed to have anything over 0. That's why it's undefined, right? Anything over 0. Not allowed. All right. So hopefully this was a nice review on slope. You definitely want to know those vocab terms. You want to get practice. You want to be able to understand slope so quickly. Like, you want to be able to look at a graph instantly. You can calculate it. You want to be able to take 2 points and you can calculate it really quickly. It will really help you in the future, and hopefully it's an easy topic.